Okay, now we're going to talk about a quotient theorem that we can apply for trigonometric or polar formed numbers and how we can divide those numbers. So what we're going to do here, we've got two polar forms that we're dividing, and we're going to write these in and express them in rectangular or a plus bi form. All right, so what we're going to do is we're going to first call out the formula, and I'm going to go straight down to the compact version of this. What it says here is you divide the two r values and then you subtract the two theta values. Okay, so we're going to do that, and let me go ahead and write this first as 5 cis of 200 divided by 4 cis of 50. All right, and that'll make it a lot easier. So we're going to have 5/4 on the outside and then cosine imaginary sign cis 200 minus 50, which is 150. All right, now we're ready to take this and write this in polar form. So let's go ahead and take a look at our unit circle. Okay, so we go over to our unit circle, 150 degrees, and the cosine is right here. It is the negative square root of 3 over 2, and the sine is this one right here, the 1/2. So let's go ahead and I'm going to put a C for cosine and an S down here for sine. All right, and I'm going to take that and go back to my problem right over here. All right, and it's going to look like this. Okay, so it's going to say 5 over 4. Again, the cosine of this was negative square root of 3 over 2 plus I, and the sine was a positive 1/2. It looks something like that. And now we're going to distribute that across the way. So we're going to end up with something that looks like this. Negative 5 square root of 3 over 8. Nothing we can do there to reduce. Plus, and then 5 over 4 times 1 over 2 becomes positive 5 over 8i. Okay, and again, nothing there that we can do to reduce that as well. So we have done it. We have taken a quotient and we've written a quotient of polar forms or trigonometric forms and written it in rectangular form. So now let's go ahead and take a look at another example. So let me move this formula down for us. Take a look at another example right about here. All right, and let's take a look, see what this one says. So we're going to say 8, let me fix that for you, 8 cis of 90 divided by 3 cis of 30. And this one boils down to 8/3 cis, and then 90 take away 30 is 60. So that's what we're looking at. We're going to be looking at the cosine and imaginary sine values of 60 degrees. Okay, so we're going to have 8/3 on the outside, and then let's just zoom over to the unit circle real quick. 60 degrees right about here. There's the cosine, there is the sine. Let me label that for you, cosine and sine. Cosine is 1/2 and the sine is the square root of 3 over 2. Now let's go back to our problem right here. Hopefully you didn't get dizzy there as we zoomed in and out. All right, so let's see here. We said again the cosine of 60 is 1/2 plus I, and then the sine of 60 is the square root of 3 over 2. And we will now distribute. All right, so we get 8 over 6, which we can reduce, and we'll talk about that in a second. And then we have 8 square root of 3 over 6i, which again we can reduce. And you do that, and you're going to get something that looks like this: 4/3 plus 4 over 3, and then times the square root of 3, just like that, I. So that's what it would look like reduced, fully reduced. And yet again, another example where we went from polar or trigonometric form in terms of a quotient, and we expressed that quotient in rectangular form. So not terribly difficult. Again, the key thing is that you understand this quotient theorem. All right, and again, the compact form is really what makes it a lot easier. But if you like this video, if it was helpful, be sure that you like and subscribe.